Now Taylor, in example 2 it says graph this equation. Now on the first day that we started this stuff, we plug in 3 x's, find 3 y's, we plot the points and draw a line through them, right? On the second day, we would find out what the x-intercept is by putting a 0 in for y. We find out what the y-intercept is by putting in a 0 for x. We plot those 2 points and we draw a line through it. Today we're doing slope-intercept form, okay? So what should I do first here to this equation? Exactly. I'm gonna write it in function form. So I'm going to subtract 3x from both sides. And how would you like me to write, oh, not 3y, but 3x. How would you like me to write it, Taylor?
Y equals 3x.
Beautiful. Perfect. Okay? This is also slope-intercept form. Okay? So Taylor, what's the slope of this equation? Negative 3 over 1. I always want that to be a fraction because it tells me the rise and the run, right? And those are my directions to the next point. Now the first thing I'm going to do is put a dot on the y-intercept. What is the y-intercept? 2. All right, so let's go up to 2 on the y-axis and put a dot. Okay? That's the first thing that I do. Now I have a point. How many points do I need, Dylan, to draw a line? I need 2. I've got 1. The equation gave it to me. How do I get to the next one? Dylan? Taylor?
Up. Wait. Over here.
Slope is rise over run, isn't it? Taylor? Down 3 because 3 is negative. Go down 1, 2, 3. And then do what, Grace? Over 1. Go over 1. Right here. We'll make that. And then draw a line through it. It's graph. That's it. It's easy. It's much faster than finding 3 points. It's faster, I think, than trying to find 2 separate x-intercept and y-intercept. You just put it in function form, put a dot on the y-axis for this, and then use the slope to find another dot and draw a line through it. That's it. Any questions about this? Clay.
Okay, what does the x represent?
What? Not just the x, but the x and the y. Okay? Think about that. Each one of these points on this line has an x and a y. And we're going to use this later, Clay, so it's a good question. If I take the x and y from any one of these points, it gives me a true statement. Okay? So because it's a solution to the equation. So for instance, let's take this point. No, let's not take that one. We already know what that one is. We went down 3 and over 1. Really? What's the what are the coordinates for that point?
The coordinates for that point would be 1 and negative.
Okay. If I plug these into this equation, it's going to be true, right? Well, I plug in negative 1 for y, okay, is equal to negative 3 times, what's the x?
Times
1 plus 2.
It'd be equal.
Negative 1 is equal to negative 3 plus 2. Negative 1 is equal to negative 1. And it comes out true with every point on that line. So do you see what the x and y is for?
Yes.
Beautiful. Beautiful.
All
right. Good job. Let's look at the next one.